As a part of EV201, we have built the motor controller. As we know that motor principle is, whenever a current carrying conductor is placed under magnetic field, the force acts on it. As per this principle, the coil is rotating. We see the basic motor and how the motor is controlled. In this video, you can see that the three coils were built, and these three coils commonly called as stator. And the stator is supplied using the battery pack, which is energizes the stator, and the middle part, which is rotating, is called rotor. And you can observe that whenever we press each switch, that switch enables the energize the each coil, and that coil attracts the rotor. And whenever the switch is pressed, that coil energizes and it attracts the rotor towards that coil. So by this way we are manually controlling this motor, and to upgrade this controllability of motor into automatic, we are going to use Arduino controller. In order to build the motor controller, we have used Arduino and MOSFETs. We know that MOSFET consists of three terminals, that is gate, drain and source. Using Arduino, the gate signal is provided to gate. The Arduino acts accordingly with the code dumped in it. When the Arduino gives 5V supply to the gate of the MOSFET allows the 12V supply to pass through it. Accordingly, with the gate signal and Arduino code, the motor can be controlled. During the construction of motor, I have faced many issues with running the motor as in the screen. And I have overcome the problems with the help of coach in Discord, and some problems are overcome by myself. At last, I have run the motor with a least delay of 10 milliseconds. I think this was a very least delay in which this motor can be run with the motor which has been made from the scratch. Now let us see about battery management system. As you can see that the Arduino is used for monitoring the battery pack. The Arduino is coded such that to check the voltage of the individual cells and also the total voltage of battery pack. And hence, when we serial monitor the Arduino, the outputs will be the individual values of cells and total values of battery pack. As we can see in the screen, this is where the cell readings and total voltage of battery pack is showing of our battery pack. Like this, our Arduino is monitoring the cells as the battery management. So, in order to establish communication between battery pack and motor controller, where we used the I2C communication, in which the battery pack Arduino acts as master, and the motor controller Arduino acts as slave. And the communication between both the Arduinos can be taken by two pins, that is A4 and A5. The A4 pin acts as a data line, whereas A5 pin acts as signal line, and the ground is same for both the Arduinos. The code in the master Arduino is written in such a way that whenever the voltage is less than 4.5 volts, the Arduino sends the signal as 0, and whenever the voltage is greater than 4.5, then it sends a signal as 1 to the slave Arduino. Depending upon the master input, the slave runs the motor. Whenever the input is 0, the motor shows the fault as low voltage. But whenever the input is 1, it turns the motor. This shows the serial monitor of master and slave Arduinos. In master Arduino, we can see the individual voltages and the total battery pack voltage, and also the temperature of the battery pack can be monitored. Whereas in slave Arduino serial monitor, we can see that low voltage is occurred as fault because the master Arduino reads BMS data as 0. So due to that, it once runs the motor and shows the fault as low voltage. This is how the I2C communication occurs between BMS and motor controller.